Robo-da, 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 zoom, zoom, Robo-da.
Hi, good morning. This is Ravisankar. I am working as the Research and Development Manager. Today we are going to see about the new technology. The technology name is called Scratch. The Scratch Advanced. Scratch Junior available. Scratch Junior is for very basic things. It's a click and drag methodology for the very juniors. And Scratch Advanced, it is a programming language that makes it easy to create your own interactive stories, animations, games, music and arts. And maybe this programming language is a block programming. So we create interactive stories not like that and animations, and we can create our own circuits and programming part and musics and arts and robotics itself. As we are the young people create and scratch so many projects, so they learn important the mathematical and computational ideas. What is the logical thing we need, and we get the idea from our own, we can apply through the mathematical and computational ideas into that. The Scratch is the integrated development environment and it is the open source, and we need not to buy anything, and it is also learning to think creatively. Creativity, how it's created. So everybody have a different idea, everybody having a different logic, everybody having a different things. So systematically we can create some logics to apply the to create the new environment and our application and work to collaboratively with the so many platforms. It's possible, and it is developed by the some of the MIT Media Lab. MIT Media Lab has created the Scratch Junior and Scratch Advanced and the mobile app inventor. The MIT App Inventor also one of the mobile application development platform, and it is also the open source. And what is Scratch? And we are going to see about the very fundamental things the next 40 minutes. Scratch is fun and educational, and it is appropriate for all ages, not for junior and high level, not for college students, not for the professionals. Anybody can use, and they can use and create the applications for, and they can post it into any social media. And we can intro to the course. There are several universities in the nations, and we can see what is the Scratch now and the programming environment. So first we learn about what are the programming environment. The user applications, they can create their own logic to create algorithm, and they create our own program into that. Then the IDE will give the perfect output for that. Here, click and drag methodology, they are applied from the IDE. So we are not going to create any instructions. Unlike C and C++ and Java and Python in the days, we are typing more number of codings in the lines, the instructions. In thousands of codings we can create. But from this background of this Scratch, the development team, so already they are created the more number of programmings and they created the functions. So these functions we call it as here the blocks. So we easily, whatever the blocks we need it by continuously. So this block is the background operations. Whatever the blocks they already created, we can easily click and drag to our applications and it is working properly. And we not worry about that the coding in the backend. So front end also, it's also like same thing like click and drag methodology. See here, so there are five, the components are available: file, edit, share, and help. So see, this is the scripts and this is costumes and sounds. The scripts is the nothing but this is the object. Any objects we can use it for the any methodology. And costumes, it is a background, and maybe you can upload your own background also based upon your idea. And there are more controls and sensings and operators and variables and sounds and looks and motions here. And sounds, what is the technology? They are already predefined sounds already loaded. Suppose if you need, you can use it that. Otherwise, if you are using your own sound also, it's possible. You can create your own voice into that video or cartoons or program. Anywhere you can simply apply it into that. See, this is the Scratch window and this is the programming environment. So now, yeah, whatever the programming we first created, we always telling like the hello world. So the same thing here we can selling the Scratch. The Scratch is now I am taken. So this is the sprite. This cat is I am taken. This is the sprite. See here. So this is sprite 1, and this is the costumes, and this is sound. And see in the left side, there are more number of controls here. So motion, looks, and sounds, pen, and control, sensing, operators, and variables. See, there are left side, there are more number of motions available. Move 10 steps, turn 15 steps, and turn 15 steps in the anti-clockwise, point in direction, pointing towards, and go to somewhere else x to y, because this window is screening by the x and y coordinates. Right now, we can go ahead the next step and open a scratch window on your computer and follow along as we explore this exciting programming tool. You can also follow these instructions. You can use your own laptop, and you can follow the instruction to create the new project in the scratch. So the command center, so this is the program area. So from this programming area, you can create the more number of blocks by the backend code. And this is the costume design setup. So whatever the objects you can create it for your application, you can make it use of this one. And this is the stage. What is the stage here? The background, or what is the, it's for example, I'm telling, like if you are going to create the one football match or any ground or any forest, if you're creating the any background image, it's available. Suppose if your own image, if you want to use it, you can upload your own image and own background. It's possible also. You can upload into and you can use in your application. And this is the display window. Whatever the objects you taken or whatever the programming you created, everything it's happened in this display window. We, for example, if we are creating in C, C++, Java, and Python, whatever the programming languages, the compilation methodology is very important, because the computer will understand only the binary languages, because the computer we need to compile the code, because we are creating the programming in high level language, and the machine will understanding only the binary language, that is called object code. So every compiler we need to convert into the source code into the object code. The same thing here, and we have to execute that code in the some command prompt, but it is not possible, but is it not need in the scratch. It is very advanced thing of environment. So at the time of we can create any objects, at the time of whatever the block codes you can apply into your what in your applications, at the same time you can run your code immediately. See now the right side we having this some flag green, and we having this some red. So this is the run, this is the stop button. So this is the execution, and this red button will be stop it. So each and every code of instructions you have to add, or each and every block you have to add it into your sprite. So it's possible you have to run your code, it is okay or not. Then suppose if it is not okay, we can change your code appropriately. And see now, in this window at the top of the programming area, we have the current status of the sprite is shown. So what is the status now? What is the position of the X, and what is the position of Y, and what is the direction? Now we have to move the sprite. It's the X and Y also continuously change. Its position on the screen is X equals 0, 0, the very center of the screen in the home position. Just like the origin is a coordinate plane graph in geometry. So and the sprite is facing 90 degrees, which can tell in something two ways. It says direction in 90, and there is a small blue line and on the sprite, and that points in the 90-degree direction to the right side. So you identify from the black, so from the blue, you are in the sprite will talk about from the 90 directions. And see some of the commands available. When you click the motion button in the left side, the controls are showing to you. Let's look at the commands and write a very simple program to get started. And see, in the motion control, there are move, turn, turn anti-clockwise, turn clockwise, set Y to something, change Y to something, and X position, Y position, direction, glide, and go to. So go to is very important. The object will move from go to using the go to command from one place to another place, and using the X and Y coordinate. And this is very important. The next control, the control having when the program will work. This is very important. We can create any kind of instructions, any kind of blockings, but where is the initial stage and where it is starting position. And here we having control. See when flag clicked. So when the click button is initiated, all the control will work. When the space key is pressed, it is a different control. Suppose in your application you are thinking about your space is using for your motion or your space is using for your control. So this is the thing you have to apply it. When sprite is clicked, so another one. So you have to click in different manner. When the flag is clicked, when space is pressed, or your sprite is clicked, based upon your application. Suppose if you are going to create the big programming concept, you are apply the more number of keys, the pressing keys, like a space keys you can use, maybe your sprite you can get used, your mouse click you are used, maybe any buttons you can use. At the time you can using this block of codes and wait for one. And I want to explain about the looping concept. What is the looping? In C and C++, Java and Python, the most of the all the programming languages, there are two different important things. One is the branching statement, another one is the looping statement. The branching statement always we having the if and else if. So we having a set of questions, sorry, set of statements within a single question. The question we having some decision making. Suppose if the question that you if you want to take some questions, the decision making we have to the question the control identify the condition is true, it moves to the one block and execute all the coding. If the condition is failed, it's automatically moved to the else block and it's displayed and it's executed some of the set of some different set of blocks. So there are two set of block of codings in the branching instructions. One is called if block and the else block. So this type of branching statements, we having more number of block of codings available into the control. And the for loop, the in basically the programming languages, they are explaining the concept of while, do while, for, etc. etc. And here in the block of codings, we having the forever or for each. So forever here we are using. So from this far, whenever the control automatically identify the condition will check whether the condition is true. We have a set of instruction. The set of instructions will continuously execute for that based upon the condition. So many times and so many times we have to run the code. So we need to put the condition for how many times we are going to be execute the same set of codings. See now when drag and drop the green flag hat and anywhere in the programming area. So this is the first step you need to do. So suppose if you are opening this scratch, yeah, scratch you want to open, the scratch program always begins with one of the four available hats. And for now only we will always start a program with the green flag hat. So this is the first hat we can add it. So in how we are going to be install the scratch, this is very important before we start the application. It is the open source and already explained, and you need to put in the Google to download the scratch advanced. It is easy to download and you can install it. And see now switch to the next command. Now switch to the motion command set and it is click and drag moves for the 10 steps. So this command, what happens, what are the sprite you are used in your application, the control is automatically it moving the sprite to the 10 steps. And this command we can use for the any sprite. So first you can set up the flag and you can set up your movements from left to right or right to left, whatever the things you need to add it. And you just add the snaps into place of the notch. This is how you add a command to the program. After that, you just click on the create flag icon top of the run your code. You just click it, so the movement is here. The X position you see now in the last screen, the X position is 0. Now the X position is 10. How it makes happen? Because of the two block of codings. So this is very interesting. You just click and drag whatever the blocks you can add it into your application. It's automatically running. When you click this flag of green and it's automatically move to the from left to right for the some directions. And suppose if you can move 10 steps, you can tell by watching the display window or looking at the coordinates at the top. The X value is now 10 and instead of 0. So this is the thing happen after execution of your code. and the cat is now in position 100, 0, which means the green flag click 9 more times. Now let's make one program to cast the cat to move 100 steps, 10 steps at a time. First, we need to reset the cat's position to the home. Click and drag. You go to X and Y also set to the 0 command. Insert it below and by above the command program. Remember to move it slowly into the place, watching for the white line to appear where you want to drop it. Now add 9 more and move commands to your program to make a total of 10 move steps commands. Then run your program to see the result. See, you think now this is the logic. Go to X, X is equal to 0 and Y is equal to 0. So this is the home position. This is the origin position. And the control move to the next steps, that is called move 10 steps. Move 10 steps. Up to the 10 times we added here. Suppose if we are not using this type of logic, simply we can put move 100 steps. It's not possible. So that's why we can add the move 10 steps for the 10 times. And the cat moves so fast that it's difficult to see the animation. So we need to add wait command. What is wait? It's it frequently moves immediate to the left to right and it is very speed. So if you can find this command, then add this into your program in the appropriate location. So guys, you have to just think now how we are going to apply the logic now, because we need to add the wait function, and where we apply this wait function, this is your logical thinking. Think about it and try it yourself before you look at the next slide. You think now? Just take a 10 seconds. Okay, you think and you have to apply. It's okay. Good, your logic is okay. Then move to the next step. What is the next step? So I am using that wait, that block into that after all the instructions into that move. If you did the right thing, you found the wait command into the control group and inserted it after each move command shown here. So what happened now? The sprite now move from left to right, not in very speed. It is very slow based upon the second. Not only the 1 second, you can use 2 second, 3 second, up to 10 second based upon your applications. Now, when you run the program, you can actually see the animation. It is a bit slow, but we can change that by using a decimal value smaller than 1. And let's wait on that. That is really cool. And we have to learn about quality loop. So, first of all, remove all but the first box from the program. To do this, just click and drag down the fifth block. All the others will come with it. So, you group of blocks you can move to from somewhere else. Then drag it back to the command area where it will just disappear. And see now, so many more number of statements we added, and this is very more complicated. And this is the first example program, so it's not a problem. We first learn about that things. But we are the good programmer. We don't want to use the same type of sentence continuously. Then it shows the execution problem, not execution problem. We having the some complexity because the execution speed is very less. What we are the programmers, we just concentrate. We need to concentrate on the execution speed of the application. For example, here we remove or eliminate all the instructions. Proof the commands are all gone. Now find repeat 10 commands and drag it over until it surrounds the bottom two commands blocks. So this type of commands is called the loop. So now we are going to use the repeat. So it will cause everything. It surrounds to repeat the 10 times. So whatever the same instructions, if you used in your application, you can use the repeat block for so much times. See now, here the white line needs to appear after they go to X and Y command and before the move command, surrounding only the move and the wait commands. Here Now the applications are the programmers, they directly go to use the repeat into that. So whatever what is the programming logic here, we remove everything and we can add the very simple instructions here, and it is the repeat one. Now you have exactly the same program as you did before, but in much more elegant form. We have a big line of instructions there before that, but we reduce it in the now 4 lines of coding. Before that, the same line of coding is created for the 15 lines. Now it's reduced into the 4 lines. But the application is same, the output is same, but the execution speed is very, very high. What happens? See now what is the program? When the flag is clicked, what control knows? The control will go to x to 0. What is the position of x and y here? X is 0 and y also 0. So this is the home position. And what is the instruction next step? The repeat model. The repeat model we having the number of times, that is called number of count. We provided the number of count, this is the 10, because the existing program we used the 10 times of instructions used. So here we can make it as the count of 10 and move 10 steps. So move 10 steps, it's move to somewhere else from x to y, x to x or y to y. Wherever you want, you have to use it. And wait for 1 second. Why we are using the wait for 1 second? Suppose if you are not using wait for 1 second command, it's move very fast. And we can show, we can, if the sprite will move quickly. So we can use the wait functions appropriately for your applications. And see now why this word, this is called elegant in computer programming, means what is elegant? Well crafted, efficient one. Yes, this is the thing I am continuously explaining to you. Efficient program we need it. And it is short. Why it is short? In the computer programming, the debugging model is very important. So this is based upon the testing part. Whatever the applications we created, it's move on to the testing part. At the time, there are more number of bugs created and changing environments created, and we need to change it accordingly. Suppose if it is a very short or elegant form, it is very easy to debug it, and it is sweet and to the point as opposed to a brute force process, which is the way we did at a first. Okay, so this is the first program you created. The sprite will move from x point to some other point, and we having a speed of, otherwise not a speed, we can tell it is the delay of 1 second. Every delay of 1 second, it's small, you can walk or running, everything you can create. And these the two designs analysis complex, and it is elegance and brute force will be used throughout all of your computer programming career. It's not only in the scratch. As you learn new techniques and refine your skills, hopefully your programming will become less brute force and more elegant. Now let's change the wait time to something smaller than 1. Why we need to change? You just change it and see now what happens. And since it is inside the loop, you only have to change it once instead of 10 times in the previous brute force exam. To change it, simply do a single click inside the white box to highlight the value. You just change the value, you can click it or double click it and change it. Then replace it with a new value and say we can call it as 0.5, and we can make the cat move twice as faster. Try several values until you find a speed you like. Now the animation is slow enough to be visible and should look fairly realistic. Maybe we can make it as the 0.5, and it is the efficient one, and its speed will be high. However, there is one more problem. Most, if not all, cats cannot move with moving their limbs. Fortunately, we can fix that too. So, see now, it's time to look at costume design, because now we discussed on the blocking coding. We discussed on the backend coding. What is the blocks? How we can use it. So it's a time to look at the costume design and editing aspect of the scratch, because the background, the costumes, everything is much easy and it is easy to create. To make any changes to your sprite, you must first select the sprite and you wish to adjust. In this case, the one and only sprite is already selected. So now to see the costumes now of the sprite, click on the costumes in the tab in the programming area, and the window will be changed to a costume editing area here. You just click it, it already shows the paint, import, camera, everything. So suppose if you want to more number of sprites in the same properties, what is the properties applied? So whatever the objects we already created in the some color, some font, some display messages, everything it is the properties and font size and color size and sorry the color everything, and it is easy to copy that. For example, if the same sprite you need it, you just copy and paste it, and we can apply for our applications. You don't want to create the same sprite for the and wasting your time. You just copy and paste and you can apply for. And you can see that despite two costumes already designed, so you have seen the first one, but can you see any difference in the second one? Because we have that the second one has the arms. So legs is different position which will cause animated effect. So when alternated back and forth, fortunately there is an easy command need to do this. How we can change it? The first sprite is different and second sprite is different. And see now, and the costume one and costume two are different things and we need to change. To find this command, switch back to the scripts tab to the program area and then select the looks like. So now what happens now? So this is the under this here the motion the looks properties here. So you just click it next costume. We having some commands next costume. They click and drag the next costume command, then insert it to your program. And maybe your next costume click it, you can change over anything here. And now run your program to see cat happily skipping across the screen. The next costume we having a different format. Maybe the every sprite you can use, you can add your next costume inside your code. Then you can see what happens, and it is very easy to create it. Now it's time for to the experiment. Another one, make the appropriate changes to the current program. And to make the cat start on the very left edge and end up on the far right of the screen. And while touching the edge, go ahead, try it. And don't look at the next slide until you have tried it yourself. And you have to apply your own logic. You think now the sprite will move from the left to right, and we can take some times. And what are all the codings and blocks available? First you can understand, then you can apply for it. Because the Scratch having the motion properties, looks properties, sounds, operators, sensings, and controls. There are more number of properties available. See now. So what is the change here? The starting x value has changed to some other minus 192. It's causing what happens. The tilde value touches the left edge of the screen because the negative values will always giving the some fastness, and the number of repetition for the loop has changed to 38. You can apply your own logic for the based upon the constant value you can apply that. So these changes were made after the trial and error steps whenever we have the errors and we can be debugged. The debug the code is approximately applied for all the application, and it is fine tuning also and the values until the whatever the outcomes we need it. So what happens now? So now let's explore some other commands. Save your program in the motion one. See the program now and then clear the program work area. So what is the program? So they are using the clean and pen up and go to and point and pen down and set the pen sizes to 10 and glide and turn the 90 degrees. So what happens? The control will directly move to the turn 90 degrees at the end. So the your sprite is turning to the right directions of the 90 degrees. And enough command to the program so that it draws a square and then moves the cat out of the way so you can see the square. Don't look at the next slide how we are going to create the square. And we having some solutions. Now we have to add some commands into the program. So go to X and we have to add this some negative values because we are in the home, because the sprite always in the first place. So X and Y, the coordinates always concentrate on the values. Whatever the values we added, so finally we can be less it. So here, what is the program we added? glide some seconds to x from the y coordinate and turn the 90 degrees, and we can use the glide some seconds to x from x to y, and we having some coordinate points. First you analyze it, what are the coordinates you have to use it, then you can apply. So then it creates a big application. Suppose you can use the any coordinates, then you can see at the time of execution, at the running time execution, you need that the sprite will rotate left or right, or what degree you need it, you can use it. First of all, a new group was used, the pen command group, specifically the clear, pen up, pen down, set pen colors, and the set pen size also. You can apply into your concept. So from the motion group, the glide and the turn commands are used. All this should be fairly self-explanatory if we observe how they affect the cat in this program, because the costumes in that sprite is effective to the runtime commands, and sounds also we can add at the runtime commands. But before that, scripts make it. Other than the our blocks coding will be applied for that, for the whatever the operators we can use, whatever the controls we have used. And there is one more cool technique that we can help you a lot with the labs we will do this session. And for the last command of this lesson, you have to figure out where to move the cat by thinking about the coordinates. The coordinates, you are thinking now, here we have the only one sprite. But in our animations or game or any big applications you created, so many sprites we are used, so many directions we applied, so many coordinates we applied. So based upon things, we concentrate on the coordinates values, then only we have to apply the technology. And this is the easier way. And go to the output area and click and drag the cat to the particular place on the screen. So the place is always in the home. So the top, say the top left corner of the screen. So drag me from the some place. So you drag it. What is the value and what is the x and y? It shows some value in the negative and some value in the positive y. So based upon that, we have taken the coordinates well. When you have cat where you want it to be, double click on the cat itself. Now look at the coordinates in the status area. The compare the coordinates into go to x, y, and glide commands, and they should match. Now just detach the discard the old go to x, y command, insert the one with the new coordinates, and then run your programs to see that cat does indeed end up in the top left hand corner. You turn this every 90 directions in the in the clockwise, maybe in the anti-clockwise itself. Based upon the program, the sprite will automatically running or walking or moving. It's creating the some squares also now. It's happened. So see the program now. When we click the green flag, it takes the pen up. This is called pen open, or the pen is working starts. And the pointing direction go to x and y. The pen down set pen color is the blue, or you can set the pen color to some other based on your application. The pen size is 1. It is the width that is called the harder or smaller, or it is a thickness. It's given the thickness of the value. And you see now the glide is the movement from x coordinates to the y coordinate. X is the 150 and y is the 0, and turn the 90 degrees. And what happens now? The pen will create the one line now, and the glide we can apply the some seconds, and we can move from x to y coordinate, that is called positive 150 to the minus 150, and once again turn the clockwise and 90 that is called clockwise 90 degrees, and the glide we can use for 1 second, and we can apply the 0 to minus 150, and finally it's moved to the starting position. So what is the starting position? 0 0 150 and 0 150 and minus 150 and 0 and minus 150. So then pen up, pen down, and pen up once again, and go to the some values. So now just detach and discard the old x and y command, insert the one with the new coordinates, then you can finally create the square based upon your sprite. So this is the thing, this is the class we completed here. This is the final session, this is the final slide. So what you have learned in this session, you learned the basic of the Scratch, very basic things we learned here and we discussed, and what are all the programming environment we learned, and what are all the many controls, motions, looks, and pen commands is all available already. We don't want to create anything, and these are all the existing properties. And now it is time to practice your new skills. And this is the session. You want to learn more about the technology and the advanced level of Scratch. You have to follow this link and you have to subscribe these things, and you can follow everything to learn more the technologies. Thank you guys, and thank you students.